Okay, in this portion of the video, I'm going to go over solving quadratic equations through factoring. And just keep in mind that some of these will already be factored, so you can just simply solve. It is multiple choice, and some of these answers are pretty obvious, but I just want to show you the method that goes behind it. So the first thing you're going to do is you're going to have to know the zero product property, which basically says that if you multiply any number by 0, you're going to get 0. So now that everything is factored, I can set it up to where r is equal to 0 or r minus 8 equals 0 in order for the whole thing to, the product of it to equal 0. So all I have to do now is solve for r on both sides. One has already been solved, and so my two answers are r equals 0 or r equals 8. So that would be letter D. The next question, again, these are already factored, and so you simply have to set them up, set them equal to 0, and solve them for the variable. And it's that simple. Now what you could do is check. When you plug negative 2 into the original equation, you get 0 times negative 8, which is 0. And when you plug 6 in, you get 8 times 0, which is also 0. Again, so that's kind of how the zero product property works. On number 22, it's not factored, so this is where we need the layer that we need to add to this is it needs to be in factored form before you before you solve it. And so it does have a GCF of v. When you factor out of v, you have two factors, v and v plus 5. Set them equal to 0 and solve for each variable. One is already solved, and so v is equal to 0 or negative 5, and that would be letter B. 24, once again, inspect it, and what you have is a trinomial on the left-hand side, and it needs to be factored. And this is the rule of thumb as you solve quadratic equations, is everything needs to be factored. And since the leading coefficient is 1, we can just break the negative 16 into two equal parts that will add up to 6. And so our factors are b minus 2 and b plus 8. Again, the zero product property says if you multiply two numbers together and the answer is 0, then one of the numbers has to be 0. So set your two factors equal to 0 and solve for each variable. And it's that easy. There you go. And of course that would be letter C. Number 26, again, has to be factored. And if you'll notice, it only has a GCF of x. And a lot of people leave out that x minus 0 for some reason when they're doing this. If this weren't a multiple choice, they just tend to leave that off. So we're going to add 3 to both sides. We're going to solve for x. This one takes a little bit more layers. So we get x is equal to 3 halves and 0, which would be letter C. Got two more. These are going to get more difficult. As we look at number 28, in order to solve, all equations must be written in standard form. And standard form is ax squared plus bx plus c is equal to 0. And so this is obviously not yet ready to be solved, so we have to prepare it. What we're going to do is we're going to just take all the terms that are on the right and put them on the left. And we're going to get a new equivalent equation. And when we look at that equation, it's not one of your easier trinomials. There's no GCF. The leading coefficient is 6. So I use what's called the box method. You're going to put the first and the last terms into the given boxes. And then you want to multiply a times c, which is 6 times 5, which gives you 30. And then you're looking for factors of 30 that equal b, which is 11. And those are 6 and 5. And you'll notice what I've done is I've just thrown the 6a and the 5a in the two remaining boxes. The order doesn't matter. Now what I'm going to do is take the GCF from the top row. Each of those terms contain a 6a. Going to do the same thing in the bottom row, and I'm adopting the symbols like I know that's a positive 5 because the 5a is positive, so you always adopt the the sign of the number closest to the box that you're working through. Now I'm going to do the column. As I look at 6a squared and 5a, the GCF is a. And there's really nothing common to 6a and 5, so you're going to factor out a 1. Then you're going to throw those into your two binomials and use the zero product property. Set each one equal to 0 and solve for each of the variables. And as you can see, the first one is negative 5, 6, or negative 1, which is letter D. One more. Again, what we have to do is prepare the equation for solving. So we need to set it equal to 0. And when I do, I'm going to put the 35p squared, which is the first term, and 16, which is the last term, into the boxes as shown. Next, I'm going to multiply 35 times 16. Now this one can be kind of, this is going to be a large number. Okay, 560. Now I know 35 and 16 won't give me a combination of 48, but I'm just trying to show you some ways to work with factors. So I'm going to break up the 35 and the 16, and 35 doesn't have too many options, 16's got a couple other options, but now what I'm going to do is recreate some numbers like 28 and 20, which does give me the 48. I'm going to throw those numbers back into the box in the remaining empty boxes and add the variable p behind them, and then factor the first column. What's common to 35p squared and 20p is 5p, and then factor out the 28p, the 4 out of the 28p and 16. I'm going to do the same thing along the first row. 7p is common to both those terms, and 4 is common to everything in the second row. So I'm done factoring. And I can set those equal to 0, and then set each factor equal to 0, and solve for each factor, each variable, excuse me. And that gives me negative 4/5 and negative 4/7, which is letter B. And that concludes this video. And here's a little shout out to Scotty for listening to this whole thing. All right, y'all, I hope you have had some success with this. We'll talk to you tomorrow in class.